Afternoon, everyone, and welcome, and thank you for joining us for this ADAS webinar on how to save money and green the highways. My name is Kat Evans, and I'm the Client Relationship Manager for RSK Habitat Management and ADAS Environment, which provides ecology, arboriculture, archaeology, landscape and planning services. Today, I'm joined by Phil Sterling from Butterfly Conservation, Sarah Wynn from ADAS Sustainable Food and Farming, and John Little from the Grass Roof Company. I'll give a more detailed introduction later. We will now switch off our webcams and go through a few So, all attendees' microphones are automatically muted throughout the webinar. During the presentation, you can post questions online for the Q&A session. As many questions as possible will be answered. Those that can't be due to time constraints will be answered after the webinar. A few polls will be asked at the end of the session. Each question remains open for about 10 seconds. Shortly after the webinar, you will receive a link to a short survey. If you could take a few minutes to give feedback, please, then we can improve on future webinars. Next slide, please. How to save money and green the highways. As you know, the combined challenges of climate change, the biodiversity crisis and recession, infrastructure operators such as Highways England and Network Rail are looking for ways to manage their soft estate differently. Biodiversity net gain is already an important KPI, as well as project costs and carbon footprint. Biodiversity net gain also means there is a greater emphasis on long-term maintenance, as well as monitoring, to demonstrate that biodiversity gains are achieved over 30 years. We're already seeing clients, designers, contractors and consultants working more closely together to help deliver these targets. For example, some award-winning schemes such as the A30 in Devon and the A19 in North Yorkshire have transformed highway verges into beautiful biodiverse habitats, rich in wildflowers and ideal for pollinators. But can we do more? At ADAS, we're always looking for innovative and practical ways that can deliver the best results. One example is when we used aerial surveying to carry out invasive weed surveys on HS2 for a fraction of the time and costs for standard surveys. Today, however, we will look at some alternative approaches to the design of transport soft estate, such as highway embankments, that consider the whole life cycle more. We will discuss how designing with low nutrient soils and recycled materials can save money, carbon and waste, and enhance nature. And we'll also look at how habitat can be incorporated into structures. We will primarily focus on highways, but these principles can be applied to all new and widening of existing linear infrastructure schemes. We hope this webinar will inspire solutions for your projects and tenders and generate ideas for creating a legacy and applications for the Highways England Environment Designated Fund. So, I'm joined today by three speakers. Phil Sterling from Butterfly Conservation, who will demonstrate how he created a nature-rich embankment on the Weymouth Relief Road, which you can see here, and saved Dorset Council over £270,000. Sarah Wynn, a carbon expert from ADAS, who will examine the carbon implications comparing the standard and alternative low-nutrient topsoil approaches. And finally, John Little from the Grass Roof Company and CIRIA Big Biodiversity Innovation Award winner, who will question current approaches and show how he incorporates habitats into structures and uses recycled materials to create low maintenance, beautiful biodiverse landscapes. Due to time, Each presentation will follow each other. I'll then summarise before going on to some polls and a Q&A session. Please feel free to submit any questions in the chat box during the presentations so that our panel can prepare better for the Q&A at the end. So that's over to you now, Phil.
Right, thank you for that introduction, Kat. I'm Phil Sterling. I work for Butterfly Conservation on a programme known as Building Sites for Butterflies, which aims to advise the construction industry and those who maintain public and private green spaces how to improve what they do for biodiversity. And this work is based on my 25 years as the principal ecologist at Dorset County Council, where I was involved in advising on both design and management of amenity areas, and that certainly included a number of road verges. Now, on the left-hand side of this slide, a road verge is designed to the standard specification of 150 ml of topsoil. And you can see just from that slide the need for regular maintenance with the mown strips there. On the right-hand side are the verges of the Weymouth Relief Road, which was constructed back in 2010. And it's got abundant wildflowers on it and virtually no maintenance to do at all. And in this brief talk, I just want to show you how this can be achieved. It's all down to soil fertility. And in this slide, there are two sections of the same verge, just about 100 meters apart. On the left-hand side is this standard 150 ml of topsoil. And on the right-hand side, hardly any topsoil at all. Basically, my colleagues, engineering colleagues, ran out of soil from the compound when they were restoring those verges. And on the left-hand side, this is a shot in April. It definitely needs cutting. And within that, you can just see a couple of dandelions. On the right-hand side, there's absolutely no need for maintenance at all. And you can already see that there are plenty of wildflowers within that. I know those are daisies and a few dandelions, but that just illustrates the point that as soil fertility decreases, the opportunity for wildflowers to germinate and thrive increases. And that's the driver behind all of this. The very best time to create low fertility verges is during the construction process, starting with the landscape specification. And on the Weymouth Relief Road, across 7 hectares of ground, I was able to specify an absolute maximum of 15 millimeters of topsoil. That is, 10% of the standard, and in many places, no topsoil at all. So that the wildflower mix, which you can see on the right, just under 30 species, that was sown either onto this tiny amount of topsoil, or it was sown onto the bare mineral beneath on the ground, and that was what was required. The seed mix was very carefully chosen. It's not a lot of species, but it includes very crucially some pioneer species which are designed to establish on bare ground very quickly. And the effect can be quite spectacular. So this is, you're looking at the yellow flower here. This is called kidney vetch, and this is it flowering profusely within 18 months of sowing. Not only does it look very beautiful, but it's an important plant for wildlife, being the only food plant of the small blue butterfly, which is a rare and declining species throughout the UK, found from southern tip of England all the way up into Scotland. But it's a species that's in decline because its food plant, this kidney vetch, is declining. 10 years on from the road being opened, the verges, this is the same verge by the way, the verges are showing this fabulous array of wildflowers from about April to September. And this is a shot in June this year, where there are genuinely tens of thousands of pyramidal orchids flowering on the verges. Now this particular verge had no topsoil at all, and is on clay sands. This is not on chalk or limestone, this is clay sands, and it's absolutely chocker with pyramidal orchids. And this particular verge has featured regularly this year on social media and in the local news. Surveys have shown that the verges now support 141 plant species, and remember we only sowed 30, so there's considerable biodiversity gain by creating the right conditions for natural dispersal and colonization of plants. But it's better than that. The species now of butterflies are of 30, and 30 species of butterfly is over half the British list. So in about a 10-year lifespan, these verges, 7 hectares of verges, are now supporting over half the British butterfly species, which I think is a tremendous gain in such a short space of time. But crucially, this particular verge has had no routine maintenance at all since it was constructed, apart from the 1.2 metre swath cut next to the blacktop. Add to this that the construction team calculated that they'd save £270,000 in not having to place topsoil on these verges, and you can see that there really is the win-win of substantial and sustainable biodiversity gain and the opportunity to save considerably on construction and maintenance costs. And this and other examples, if you don't already know about this guidance, then do take a look at it. It's set out in Plant Life's Managing Grassland Road Verges guidance. So in summary, low fertility soils, these are the key. They really can deliver biodiversity gain quickly and sustainably, and indeed at low cost. There is considerable potential for reduced costs of construction and indeed establishment. And thinking about establishment, if you're sowing wildflower seed directly onto subsoil, there is no weed burden within that soil because it's never been exposed to noxious weeds like ragworts and thistles and docks. So there's virtually no weed spraying to be done. And then there are these considerable reduction in maintenance costs. And that's a subject that Sarah in the next talk will turn to in terms of the greenhouse gas savings. But crucially, this is a really important landscape benefit. You really can make verges look beautiful with very little topsoil. And that is also a matter that John will talk to us about later. So the other really critical one is highway safety, is that this is much better on visibility. There's very little maintenance to do, and you can be assured that wherever you've designed in a visibility display with low fertility soils, it will continue to deliver for you. And then last but not least is public engagement. These verges look very beautiful and people like them. And this is a really good way of engaging with the public on some of our linear infrastructure schemes. Now, these things are not without issues. I do accept that. And in particular, how do you deal with materials balance? Now, what do we do with the topsoil that we don't want, what we would normally have put on these verges? Clearly, there are issues, but I put those out to you as being, these are issues that need engineering solutions, rather than we need to go back to where we were putting on our standard topsoil mix. Anyway, thank you for listening. And I will now pass over to Sarah Wynn from ADAS. Thank you.
Hello, and thank you for joining us. So I'm Sarah Wynn. I lead the ADAS Sustainable Food and Farming team and come from a background of understanding the climate impacts and the carbon impacts of agricultural practices and land uses. And therefore I've applied this understanding and knowledge to the highway scheme that Phil has been talking about. So I'm going to do a very brief introduction to climate change and then talk about some of the impacts within the maintenance system of this approach to highways management. So climate change, from a global perspective, this really is a problem for all of us. There is evidence that the Earth has warmed over a degree in the last century, And this warming is leading to increased extremes in weather and more unpredictable weather. And this has challenges for our food production and also things like availability of water, impact on the natural environment, how you manage these roadways, because if you've got periods of heavy rain, you're going to have excessive rain, water runoff through the systems. So it's a responsibility for all of us to try and tackle climate change in a variety of different ways. And from the UK perspective, the UK government in June of last year committed to net zero. And this basically means that we need to have 100% reduction in greenhouse gas emissions back to 1990 levels by 2050. And it's covering all sectors. So every aspect of our society is going to need to take action in order to reduce emission. In March 2020, there was a decarbonising transport plan that was released, which had a strong focus on vehicles. But there's also the road investment strategy that has a commitment to environmentally sensitive green infrastructure, and that also puts emphasis on reducing the climate impact of the infrastructure that we're using, including highways. So when we look at highways and we think about the carbon emissions associated with the construction of them, and we're particularly looking at the soft edges to the highways, the embankments that Phil was talking about. So there are embedded emissions that are associated with any raw materials that are used within the construction of these areas, the aggregate, the concrete, the steel, the plastics, etc. And then, of course, there's any fuel that's used for moving those materials around. So any digger movements for applying, any truck movements for moving the materials about. And then when you come to look at the management part, you've got fuel use that's associated with any mowing, tree cutting, closing roads, checking sites, etc. And any embedded emissions associated with the raw materials used in repairs or management of the soft infrastructure. And the graphic that shows you in the middle shows basically how we do a carbon footprint assessment. You've got indirect emissions associated with scope 2, you've got indirect emissions associated with scope 3, the direct emissions such as fuel usage within your control, and then indirect emissions associated with downstream applications. And the assessment that I've done here is a very basic assessment of the fuel usage that's associated with the management of these road verges. So if we look at our site, we've got a standard construction, would be a 7.1 hectare of embankment, topsoil depth of 150 millimetres, using a total volume of topsoil of over 10,500 metres cubed. If we go to Phil's prescription, and he talked about applying a maximum of 115 millimetres of soil, and actually over the entire area, the average ended up being 7.5 millimetres on 3.5 hectares and nothing on 3.6 hectares. So in total, that construction used just 263 metres cubed of soil, which is a significant reduction on the volume of soil that was moved around in order to do a standard construction on the same area. And when I've come to do my carbon assessments, I've used a set of standard assumptions. So I've assumed that the topsoil has been stored in a heap about 400 metres away. It's been moved using 20-ton trucks, and it's been spread using a 20-ton tract excavator. And if we look at the maintenance options, well, I've looked at 3 different scenarios. There's a standard maintenance option. There are 0.6 hectares of this site that is too steep to mow, so there is no maintenance that is done on those in any of these scenarios. But on the 6.5 hectares that is of a sufficient gradient that it can be mown, my maximum treatment is to mow it twice a year. In a minimum approach, we might just mow once every 4 years, and that mowing would include the mowing of both scrub and grassland. And if we look at the low topsoil approach, those beautiful verges that Phil was showing, actually we're only going to need to mow once in 20 years. To date, that hasn't needed a single mowing activity. It's 10 years old. but the expectation is that by 20 years, something might need to be done. And the general assumptions associated with the maintenance is that the mowing has been done with a commercial zero-turn mower, that it takes about half an hour a hectare to mow grass and a little bit longer to mow grass and scrub. So if we look at what this looks like in terms of greenhouse gas emissions, I've got in this graphic here, on the left-hand axis, I've got vegetation height. On the right-hand axis, I've got greenhouse gas emissions, and the blue line you can just see starting to the left of the word initial are the greenhouse gas emissions. The brown layer represents the thickness of the topsoil that has been applied. And you can see for the very first part of this, the construction, we've got multiple truck movements, multiple digger uses that are required to spread this large volume of topsoil. And that has with it an associated greenhouse gas emission cost. We then move into the management phase where we're doing this mowing activity twice every year. And each time the mower goes in, it uses a volume of fuel, which has a greenhouse gas emission associated with it. So although the vegetation level is kept short, we can see that every year there is a cumulative impact over the 20-year lifespan of this assessment of increasing greenhouse gas emissions. So if we look to the reduced mowing prescription, you can see the vegetation height is going to get a bit higher. We've got this nice fertile soil, so the grasses are going to grow to height. You're going to get a bit of scrub developing. And every 4th year, we're going to come along with a mower and we're going to mow that grass down to a shorter height, and then the cycle will repeat itself. Because we're only bringing the mower in once every 4 years, the greenhouse gas emissions associated with the maintenance are significantly lower. They're 85% of the emissions that were released from the maintenance in the previous scenario. But we still have the high emissions associated with the construction phase here. So if we now look at the low prescription option, the blue line at the bottom is my greenhouse gas emissions, and the kind of orangey line is my vegetation height. And you can see that there are a small number of emissions associated with the construction. That 263 tons of soil needed to be moved around, so it required some emissions, but minuscule compared to the previous prescription. And then we've just got a single maintenance cut. So you can see on the right-hand side of my axis, there's a tiny tick up. That is the mowing. So the total emissions from this new prescription are 97% of what you would have seen in the maximum standard prescription, where you're mowing every year, twice a year. So in conclusion, the use of low topsoil prescriptions significantly reduces the fuel requirements for construction. Now, I haven't included any emissions associated with using that topsoil elsewhere. So there would be a bit of a balancing act that would have to be done depending upon how that topsoil is used. It also significantly reduces the fuel required for the maintenance because of fewer mowing operations. And if you look at that 20-year lifespan of the project, you could see that the emissions from the mowing far exceeded the emissions from the construction. And the total emissions reduction that can be seen is about 97%. And the chart on the right just shows you that all together. So I am now going to pass over to John Little, who is going to talk about the beauty and the joy that some of these construction approaches can give.
Hello, thank you, Sarah. And hi to everyone, and very good of you to all turn out and listen to us. I suppose I'm going to be concentrating on the potential of getting topsoil out of our heads, removing the yoke of topsoil, really, which it can be, and also just talking about the potential of new landscapes. We underestimate how good new landscapes can be if they're designed correctly. And within a very short time become amazing places. So we really should remember that. And It struck me having some involvement with highways over the last few years and getting an indication of how the systems work. It feels to me like there's a lot of work goes into this, to working out what we're going to destroy, and that, I guess, is obligatory and has to be done. And there's not enough work and not enough ecologists and inspirational thinking about what we leave behind when we finish a scheme. That's where I think the money should be spent, and that's where the emphasis should be. And if we do that, we can often recreate a habitat that's better than what's been destroyed in the first place, for sure. So I think that's really something we need to kind of focus on, because it's a very exciting place to be, the potential of new landscapes. So if we look at the whole topsoil thing, I mean, you know, what happens when you dig a gravel pit or a chalk pit and leave it alone for a while? Bang, it becomes a triple SI. You know, I mean, we know that we understand that low fertility, diverse, interesting topography, unusual substrates or mix of substrates are potentially amazing for biodiversity. So we really need to remember that when we're redesigning new spaces. And just as an example, there's a place down near us here in South Essex called Canby Wick, looked after by BugLife, the third most recorded species of invertebrates in the UK. Now, this is a place that's basically just been left 40 years ago as a post-industrial site, left, right? We didn't even design that, did we? We just left it, and it now has become that important. So can you imagine how important we could make new landscapes if we designed them, learning from these old brownfield sites? Absolutely incredible place. And if we could sort of think about that with any new landscape, and especially with highways, would be great. So we've been messing around with this. This is where I live. I'm lucky to live near Basildon in Essex, and we've been trialing construction waste, mineral soils for about the last 20 years, and it is amazing, incredible, how these places can become fantastic for biodiversity, incredibly good for plant diversity, and as Phil was saying, very, very low on maintenance. The more organic material you put in the soil, the more maintenance you're going to have. It's as simple as that. It's a direct correlation. So if we can just stop and think, when we're designing, when we're doing any construction work, we got this kind of stuff laying around, and we've either brought these. I mean, there's a scheme up the road from us here. They brought in loads of crushed brick and concrete. It's a temporary roadway. They produced lots of sand from the construction work. All these materials that are made during the construction of these works are potential substrates and topography and wildlife habitat. And this stuff is way better than dumping a load of topsoil on top. Believe me, it is. So let's think about what we've got on site and what we've produced on site, and let's reuse that back into the new landscape. Let's get slightly creative with stuff, you know. And the habitat, the substrate and the soil itself is, we think of it as a place to grow plants, but it's also very importantly a place for invertebrates. And this kind of slightly sparse open habitat, this kind of open mosaic habitat, is increasingly rare and incredibly important, and supports a massive selection of invertebrates. So we've really got to remember that, you know, in the process. So we've got to try and, if we can, get away from what's happening. You know, there's a beautiful sandbank created, pretty flat but beautiful, and then there's the 6 inches of topsoil that get dumped over the top, pretty much obligatory. Now, you know, there's obviously discussions about where we can get rid of the topsoil, can we get rid of it on site, and if we can't get rid of it elsewhere, then how can we design it back into the site? It may be that you have thicker topsoil in some areas, allows you to have this mineral soil and base substrate in other areas. It's just a discussion. We need a discussion, and we don't need to be doing the same stuff all the time. And then there's the opportunity to get the habitat into just every infrastructure. It feels to me with the climate emergency that we need to, everything we do, we need to think about habitat and how we can squeeze it into it, whether it be signage, whether it be crash barriers, whether it be bridges, whether it be acoustic fencing, anything. We just need to have a discussion. You know, I mean, we're not suggesting it happens everywhere, but we're suggesting that it's given some thought. We've done a little bit of work with acoustic fencing using sand-filled perforated sheet steel, great for an acoustic barrier and a brilliant place for ground nesting bees to nest. So that is, all this stuff has potential for wildlife. And I'm just working on a scheme at the moment, a car park scheme. Car park's another great place. You know, I mean, car parks, again, you've got this lovely, you know, free draining substrate that they're all built on. If we can just think at the design stage of a car park, how we can create landscape and habitat using the construction materials that you're going to use to make a car park. So that's so much cheaper. We don't need to be doing anything fancy. We just need to be moving around the stuff that you've already got on site. Incredible opportunity, car parks, paths, all sorts. So I guess just to not lose sight of this, just to finish the talk really, that it is joyous to work with these materials. It's joyous to be reusing materials, and the landscape that's created and the plant diversity that's created by thinking about substrate is beautiful. I mean, beautiful. We get people down to our place. We open our garden. This is the landscapes that people love. I've got plenty of traditional meadows going on in my garden, but this kind of slightly open, sparse landscape is joyous, and it's where all the action is. So that's where we should be, I think. Good. Okay. Well, I'm going to pass you back over to Kate.
Thank you, John. Thank you to all the panel. Really enjoyed those presentations. So just to summarise, Phil demonstrated how the use of low fertility soils on soft estate can deliver significant biodiversity gain quickly and sustainably at a low cost, as well as delivering further benefits. Sarah then compared the carbon emissions from the standard and low topsoil approaches over the construction and maintenance phases, and showed how the low topsoil prescription could result in a reduction of up to 97% due to reduced fuel requirements. And finally, John explored how multifunctional structures and low fertility substrates, including recycled materials, present opportunities for greater diversity of habitat and nature, as well as other benefits. He also touched on the importance of nature for bringing joy and beauty to our lives, maybe so that we can all enjoy our travel experience more. Next slide, please. The overarching message that all the panels seem to be asking is there another way of looking at transport infrastructure? Rather than minimizing impacts, can new transport routes be an opportunity to create a more beautiful and biodiverse landscape that we enjoy? Better for nature, better for sustainability, better for well-being, and cheaper and safer. But how can we all come together across different disciplines to help deliver this? One way may be via the Highways England Environment Designated Funds, which looks for opportunities to improve the environment and suggests their vision for a greener or more sustainable road network. So we've now come to the end of the presentation, and it's time for the polls. If we can go to the polls, please. Thank you. If you want to vote, then you'll need to make sure that you're in the Windows view rather than the full screen, so that you can then click on the options. So the first question is, are you designing no or low nutrient topsoil soft estate into your schemes already? And if you can select one of these options, first one is on all of your projects already. Option 2, most of your projects. 3, some of your projects. Or finally, none of your projects. So what we're interested in here is to see how much is already being applied, or are there more opportunities to incorporate this approach into more schemes. And so, just getting the results now. So I think that's a really interesting result there. It looks like the leader is some of the projects, which is great to see. It suggests that people are aware of these approaches and wanting to apply them when they can, but there's definitely room for improvement. And still 40% saying none of your projects, which hopefully are following this webinar. There'll be more opportunities or more ways that we can help enable this. Let's go to the next poll, please. So the question here is, apart from tarmac, are you already using recycled materials in your landscape? So are you using these materials in around your infrastructure schemes? And the options are, again, firstly, on all of your projects. Secondly, most of your projects. Thirdly, some of your projects. And finally, none of your projects. And again, it'd be good to find out if there are more opportunities and to apply these principles. So again, a similar, well, actually an interesting result again, some of your projects. So it looks like people are already aware of using recycled materials. And I wonder how many are using them purposely for to create a sort of low nutrient topsoil for biodiversity and slow growing vegetation, better for maintenance and better for health and safety. Right, we've come to the end of the polls. So thank you everyone for taking part, and it's time for questions. So if everyone can put their cameras and mics back on and join me to answer the questions. And I'm just going to have a look at the questions now. So the first question we've got here is from John Mason to Phil. What is the best way to improve an existing verge with deep topsoil? Remove and replace, or can we just place subsoil on top?
Well, thank you very much, Kat. That is a fascinating question. We certainly can reduce the fertility of existing soils on verges. So we've got already deep topsoil, and that is all about cutting the vegetation during the growing season and removing it. Because remember, for every bit of fertility, as much of that as possible, plants are converting into green growth in the following season. So if we take it away as much and as quickly as we can, we will end up depleting that soil and it will grow a lot more wildflowers. So it's possible to do it without actually, all you need to do is manipulate the vegetation. On the other hand, there are some very good reasons for wanting to remove layers of topsoil which are in highly expensive places to maintain on a regular basis. And there I'm thinking of central reservations, dual carriageways on the strategic highway network, where regular maintenance is required, where you're having to shut the road, traffic management, night works, where it's incredibly expensive just for the TM to do the works. Then a modest scheme to go in there and remove the topsoil and replace it with a kind of type 1 aggregate or chalk limestone with dust in it, is a really good way of doing it. Absolutely will cut the maintenance to virtually nothing, and of course is a lot safer and cheaper to operate. So I mean, there are certainly things that one can do. but you've got to find the right place to do it. And I'm just having flipped through the questions. I see there's another one where we've got existing landscapes that are already doing quite well. They may be rich in scrub and trees. We're not talking about taking the life out of those. We're saying this is in particular the design of new schemes, or where there's a particular good biodiversity or landscape reason for wanting to change what we've got already. So that's the approach that I would take. Is that it's everything to play for here. There's a real opportunity to make a difference, but one of the big drivers is the cost associated with maintenance.
Yeah.
Well, can I follow on to that just quickly? We've tried both ways, either removing the topsoil and then using substrates, and we've also tried poorer substrates on top, directly on top of topsoil. So if anyone wants to talk about that, I can give them some examples of what we've done here.
Thank you, Phil. Thank you, John. Sarah, do you have any comments? Or
No, not.
What I was also going to say is that this also applies to any place that's hard to access. So those low maintenance requirements are really applicable to sort of railway schemes where it's difficult to access them. Or any other project where you're going to have problems with access. Thank you. So I've got a question for Sarah here. It's from Joe Bradley. Have you considered the difference between carbon sequestration of the wildflower and low nutrient soils and the richer soils with grassland? Has that been included in the carbon budget? Thank you.
So I have not included carbon sequestration in the carbon budget. There's a lot of uncertainty around carbon sequestration, but the low topsoil approach would sequester very little carbon. There is no substrate into which the carbon can be sequestered, really. So my view is that really what you want to be doing is you want to be placing that topsoil in a location where you can use it better to sequester carbon and capture carbon both within the soil itself and within the vegetation without needing high levels of maintenance. So if you're able to put the topsoil on the other side of the bank, the top of the bank, away from the road, so you can capture more carbon in those places and not need to maintain it, then you can actually have a benefit in both directions. But at the moment, just using a very thin sprinkling of topsoil on a relatively sparse surface wouldn't give you a huge amount of carbon sequestration in that place.
Could I just to quickly say that there's been some work at Newcastle University with Mark Goodyear, I think, has been involved in it, looking at urban soils and when there's concrete and rubble within soils and how they found they capture carbon incredibly well without having the organic content. So that I could always send people a link on that if anyone's interested.
Thank you. Thank you, Sarah. Thank you, John. Next question. Again, this is for Phil. Hi, Phil. It's from Hamish Critchell Ward. Hi, great presentation. Just wanted to know if there are any additional engineering requirements, nature-based or otherwise, to ensure embankment stability. And does an open landscape like this cause potential surface runoff issues? Certainly with an increase in extreme weather events, that's an important consideration. Thank you.
Well, that is a very good question, and the answer to that is it depends on the materials that you're working with. I mean, clearly where you're dealing with hard rock substrates, which I would include relatively soft chalks, then that isn't going to be an issue at all, and that's all about getting the effectively the slope stability to the natural geology of whatever material it is you're dealing with. When you start to move into sands, gravels, green sands and clays, where there's increasing amounts of silt associated with that, then there has to be the potential for runoff, and that is all about working with the design engineers to get the cut slope at a level which they considered to be geologically stable. all materials will stabilize naturally. So even free flowing sand at some point or other, 12 months, 18 months after it's been cut, will stabilize. All materials do stabilize. But you can imagine if you were cutting into free flowing sand, you would need to do something in any case with a bit of geoengineering. I mean, there I suspect you would need matting. No amount of topsoil that you place on top of loose sand will actually really fix the stability issue. So I kind of think it's a bit of a sort of false premise that topsoil is what we've used in the past in order to stabilize slopes. What we've tended to do is to use topsoil plus then a particular vegetation type, and often it's been, I don't know, Westerwold's annual ryegrass that has been sown on there, which is quick growing, and that tends to create a root zone that helps to stabilize the material. Now that does work, but it's just very biodiversely dull. And I think we can be using some of our native species to be doing that. So something like common bird's foot trefoil, which has an enormous root network underneath this kind of rather low growing, discrete areas of planting, but they have a wide network underneath. So I think there are things that we can do to help stabilize materials where that's necessary. And I think it's about asking the question, but there will undoubtedly be some places where you will need to take additional engineering measures, such as digging swales, in order to collect that runoff material during the early stages of that stabilization. But that in the end of it, all slopes will end up becoming stable, unless they are in utterly made ground. That would be my view.
Thank you, Phil. Anyone else like to comment? Or I'll move on to the next question. Okay. This is the one for John from Joe Bradley. Hi, you're creating beautiful habitats for insects and wildflowers, which I love. But in Lancashire, our motorway embankments are covered in dense scrub and shrubs, which create fabulous impenetrable habitats for birds, mammals, and insects. So how do we decide? Oh, have we covered this already?
Phil's covered it really. We're not suggesting that we remove existing landscapes. We're just suggesting ideas for the new landscape. Really.
Sorry about that. Next question. This one's from Katrina Stanhope, and it's for Phil. Are there situations where there is a lot of soil overburden on a scheme, in which case something needs to be done with the topsoil? Could it be sold to another project as topsoil is a valuable resource?
Well, I think that's an extremely hot topic, if you like. I think it's something where there is generally, in my view, and criticize me if otherwise, where there's a need to retain as much material from one scheme within the scheme. So effectively, in terms of soils, a scheme consumes its own smoke. So what do we do when we do have, if we're all going to go down the line of lowering the amount of topsoil, what do we do with this excess? And I think we need to find sensible, creative, and legal ways of dealing with it. We need to understand what's in that soil. So we might need, if it's going to go off-site, and there's no particular reason why it shouldn't be sold into market, but there are restrictions associated with that to do with licensing, for instance. And so we would need to know what's in that soil and where it can legitimately go. But what I would suggest is that when schemes are being designed, we do need to think carefully about, if we are going to go for a low topsoil soft estate, could we use the topsoil close by? Because moving topsoil any distance is a very expensive and greenhouse gas hungry process. So for instance, what about the agricultural land next door? Because we know this land, we need topsoil. It grows our crops, it grows the food that we eat. And if there's a chance of temporarily taking on an additional bit of land for supercharging farmland very close to the scheme with additional topsoil, is that a possibility? and I think we should investigate that. You know, it's one of the challenges out there. But we know by continuing to do what we've always done, we are creating ourselves a long-term maintenance burden. And in some respects, we are just cutting grass, amenity grass forever, and it's not doing anything very useful. So we have to find some other ways of doing it. And just a last point is that on the Weymouth Relief Road, we did use quite a bit of the topsoil in the process of making the soils for the new rugby club that was indeed within the red line of the scheme. So we had already planned to be reusing some of that topsoil as part of a landscape restoration, in this case for recreational enjoyment.
Can I just say quickly, just following on from Phil again, I think it's good not to just stop at highways, and because obviously there's massive schemes and massive issues of if you need to take the topsoil away. But this, what we're saying, is going to apply to new developments. You know, any piece of infrastructure where the topsoil often is removed before the construction takes place, and there needs to be consideration of where that could actually go, where it could go within the scheme, or whether it could go to another place where it's much more useful, because it's a precious thing, topsoil. We shouldn't be sticking it places we don't need it.
Absolutely. So seeing it as a resource, valuing it, but I also appreciate that it's it can be quite tricky. I know that with moving topsoil to farmlands, there's a lot of tests that have to take place, and agricultural impact assessments that have to be taken into consideration, and there's also all the considerations with regards to the Environment Agency. But thank you. I think
maybe on a development they could put thicker topsoil on their back gardens and then not use it in the main landscape. Most people would be happy about that.
Thank you. So another question here. This one's to John. Where can we find out more information regarding the sand-filled acoustic barriers?
Well, they're only things that we've tried. They're just things that we've tried here. You know, get in touch with me and I'll have a chat to you about it and see if I can let you know what we've found from here. Sure, no problem.
And another question here is, let's have a look. Oh, I think no, we've done that one. So just trying to see if there's, I've got a quick question here. Will the webinar be sent out to participants, or can we re-watch at a later date? Yes, a link will be sent out afterwards. So everyone who's registered will receive a link to this webinar. Just having a look to see if there's any that are. One for Phil. I like from Anthony Firth. I like the appearance of the wildflower verges over grass, and presumably looking at the pictures, there is no need to do any routine maintenance.
Yes, well, I mean, there are various issues with this. I mean, low fertility is not an absolute panacea. You know, otherwise I suspect we would have come across this years ago. Is that two things to say. One is that depending on the intrinsic fertility of the subsoil material, or indeed the depth of the topsoil that's gone on top, that will determine the amount of maintenance that is required to maintain that biodiversity. So the richer the topsoil, and if you have managed to get wildflowers in that, in order to maintain the full complement of species, you'll need to keep producing that fertility, because soil fertility arises from a range of different factors, which include intrinsic soil fertility, you know, intrinsic materials within the soil, from the rainfall, from aerial deposition. So there are various routes in for nutrients. What we're saying here is that if you start off with very few nutrients in the system, you will end up having very little maintenance to do, and that's naturally going to produce you an extremely biodiverse ecosystem. So the lower the fertility you start with, the less maintenance you're going to have to do, but it's not an absolute. And one of the factors I do want to stress is that we do need, if we're not going to be mowing constantly, we do need to think about one area, and that's invasive non-native species of plant. Because for those of you who are in southern England and have driven up and down the M3 cutting through Twyford Down, that celebrated scheme, you will notice that the very steepest verges there are now a buddleia wood. Now buddleia, yes, it attracts lots of butterflies and the rest of it, but it's a non-native invasive species, and it's at 100% in terms of its composition of that habitat, and therefore it's choked out everything else. That's an extreme example, but I do think within these low maintenance verges, we need to make provision for the potential for these sites to acquire over time some of these invasive non-natives. And there I'm really thinking of buddleia and the various species of Cotoneaster, wall Cotoneaster and large leaf Cotoneaster, which have a habit of just appearing. On the Weymouth scheme, we've got about 0.5 of a hectare, about half a hectare of the 7 hectares of virtually no topsoil verges, which happen to have buddleia on them. And I cannot tell you why it's come up on that half hectare, but not any of the rest of it. So there's nothing that I could predict, or so it could happen. It could happen on your scheme, and it could happen. But on the other hand, it's perfectly controllable, and it's much, much cheaper than putting topsoil on there and maintaining it forever.
Do you want to, do you find, sorry, do you want to comment, John?
Say, Kate, yeah, I was just going to say, Susan has put a question up to say that they used excess topsoil for allotments on a project that was quite close to their site. So that's really rather nice. So good for you, Susan, for sure.
And I think, we do need to think about, can we use, on the assumption that we're consuming our own smoke, if we put topsoil where we want to grow trees, then that is more fertility to get those trees and scrub and the rest of it going, which is a kind of a carbon thing, isn't it? We're into trying to produce habitats which are sequestering carbon in the long term, and so it's how we use the soils, not necessarily we need to get rid of the stuff. That there are probably relatively simple, clever ways of using the topsoil within the scheme, but that thus far we've just defaulted to putting it into amenity grassland.
Thank you, Phil. Sarah, would you like to comment on the carbon element of that?
Yes, I would agree with Phil in that I think placing the soils in a location where we can make best use of them to capture carbon is going to be far more beneficial than spreading them in locations because that's part of a standard prescription. So being able to place them in areas where you can grow woodland and provide that sort of biodiversity as well, because if you've got your low nutrient grassland and you've got your woodland, you're providing extra levels of biodiversity, aren't you? And that woodland can capture more carbon in its vegetation than a grassland, or in particular a low nutrient grassland, can achieve.
Thank you, Sarah. I'm aware that it is nearly 2 p.m. now, so many of you will need to go. So thank you for joining us, and I hope you found the webinar useful. For those of you who have a little bit more time, we still have more questions, so we may stay on a little longer, and you're welcome to stay. So I'm going to carry on with the questions. Let's have a look. This is a question from Mark Jones for Phil. How do you recommend dealing with Class 1A subbases on cuttings and embankment?
Excellent. Thank you, Mark. I think it does depend on what that Class 1A contains, I'm afraid. It is that, from my point of view, the best Class 1A material is that which contains, from a biodiversity point of view, is something like a 20 mil to dust. 20 mil because it's kind of manageable. Dust, because the dust provides you the matrix in which the wildflowers will make the roots. It also helps that substrate to hold water, and that's clearly pretty important. So if for instance the loader type 1, the 20 ton or whatever it is that's delivered in, has no fines in it at all, and say it's all 40 mil, type 1, which it could easily be, then that material is won't grow any plants, or it will take a very long time to grow plants, particularly if it were a type 1 mended limestone, which has got almost no fines in it at all. So it absolutely depends from a biodiversity point of view on the detailed specification, almost lorry by lorry, as to what's within that. Once it's on the slopes, providing it's put on as an engineeringly stable batter, then that's it, and it will stay there. Now, so that type 1, even if it grows no plants, it won't have any maintenance associated with it. So I don't know whether that was the kind of the angle of the question you were after. If it isn't, then pop another question and we'll see it. And I know, John, you want to make a comment.
Yeah, because we've planted into a lot of type 1 and type 1 granite, and again, fines. The standard sort of type 1 you buy, whoever the fines in is great. And we've also used crushed concrete as a type 1 alternative as well, which is a bit cheaper. And that's really interesting because the fertility of that is that much lower again, and the stress is that much lower again compared to the granite. But that produces some really interesting short down plants that can't stand any competition. Things like wild thyme, for instance, it grows absolutely incredibly in crushed concrete, pure crushed concrete, because it eliminates the competition. So it's just a fascinating place to look at the soils and what habitat and what plant mix they create. So you dictate the plant mix by the soil, in effect.
Thank you, John. Thank you, Phil. I'll go on to another question here. This one's from Charlotte Smith, again for Phil. I've been advised that hogging should be used as the top surface layer on a highways project in a heathland area where we don't have enough in situ topsoil to create this layer. But it sounds as if you're saying subsoils are good to use even if they don't have the heathland seeds in it, which the top layer should do. The whole idea of this scheme is to allow natural regen of vegetation. Have you ever used hogging as a topsoil substitute? I know that you've been involved in heathland projects, Phil. So
yes, I definitely have, Charlotte. A good one. Hogging and hogging. I mean, hogging as in path hogging, where if you roll it with a roller, it forms you a nice flat path. The nice thing about hogging, it has virtually no nutrients in it. And if you think about what you're trying to create in terms of heathland or acid grassland, that's exactly the substrate you want. But it could be that that's a little bit too clayey for establishment. But I only say could because much of my experience is on restoration of landfill sites and of sand and gravel restorations in Dorset, where numerous sites where we've ended up, frankly, with material that just is unsaleable to be used in the restoration of the land. So one of my best sites is near Warmwell, outside Dorchester, which was restored back in the mid-1990s, and it was restored with silt, so out of a silt pond, which is clearly unsaleable. And when that was smeared over the surface, other than the fact it didn't have gravels in it, it frankly looked like hogging. Also, for the next 5 years, it looked like a moonscape. Nothing whatsoever grew on it. And we'd sowed onto that a mixture of chopped heather and hemp to try and create a substrate. And I think myself and the operator and indeed the consultant involved thought that nothing honestly would grow on that. 10 years later, harvesting the heather from that site and using it for restoration on another site. And the one thing that I just urge you to be is patient with heathland. I mean, I think hogging is a perfectly okay substrate. It will weather in time to produce a crumb that enables heathland to get going. And it's about being very, very patient with heathland. If you try and speed up heathland, you will end up with Yorkshire fog and grassland and gorse and birch scrub. But heathland is one of those very, very slow growing habitats. And if you can persuade your clients to be very patient with it, then it will almost always produce heathland. And you know, at a time when we're about to go out and play, then next year perhaps you know, do contact me and I can take you to see a number of schemes. You know, yes, 10 to 15 years later, these sites are looking really quite splendid heathland. One of those is a wonder. I mean, I would be delighted to have it as a local nature reserve, other than the fact it's got gas vents coming out of it. But you know, it is a beautiful site, full of butterflies, full of wildflowers, and all you'd expect. That was restored from reject clay sands out of a silt pond. So tricky one, and it's about being very, very patient with this.
It's just a tiny thing. We trialed Ogden here, and one is the bees like it because the holes hold together when they burrow into it, and we found it. We sowed it with a mix, but it did germinate relatively reasonably. And once the plants were established, they grew perfectly well. The only thing, obviously, in the summer, the heat of the summer, it bakes pretty hard. So we found the bee species reduced in midsummer when the hogging basically baked to that consistency. A minor piece of detail.
Thank you. I've got another question here for Phil. Does a more biodiverse landscape correlate with more mammals in the habitats? Are wildlife runs considered to reduce roadkill? And that's from Hamish Critchell-Ward.
Well, I mean, a good point. You know, there's always controversy associated with biodiversity in roads. Are we simply creating a network of biodiversity hotspots, which we then crush as we whiz up and down our roads? And you know, there is evidence on both sides for this. You know, this is not all one way. So what I would say is there's very little point in creating narrow strips of biodiverse habitat right next to strategic highway network, which is just a few meters wide. There may be good reasons for wanting that to have low maintenance, but to max out the biodiversity within, you know, 1 to 2 meters of the road, and that's it, is probably not a good idea. On the other hand, if you think of the strategic network and the width of the road verges that we are creating, you can create habitat where there is, you know, almost no contact with what's going on up and down the carriageway in terms of the carrying the traffic. Is much of the biodiversity is getting on with its own life on those places, and that the observations on roadkill are slight. There are times when we can definitely create roadkill, and so if, for instance, we've created a beautiful verge in the middle of the summer and we go and cut it, then we shouldn't be too surprised when all the bumblebees decide that they've got to go somewhere else and find their nectar, in which case they will inevitably be flying across the carriageway and indeed out into the open landscape to try and find more nectar. So we do need to think about that, and it's a very valid question. But my feeling is that where we are creating broad, wide, long verges, that's the sort of place where we want to max out on this low fertility. You know, for the rail infrastructure, for instance, where we would definitely have railing cuttings with broad slopes. That's the sort of place. And the other thing to think about is that we are trying to rebuild biodiversity in this country. You know, we're following the principles of the Lawton Report of bigger, better, and in this case, more joined up. Clearly, our linear infrastructure is the very place where we can start doing this joining up. And therefore, we may just have to accept some minor collateral damage in achieving that aim, but we definitely need to do it.
Thank you, Phil. Anyone else like to comment, or shall I move? I'll move on to another question. So another question for Phil.
Okay.
What are your suggestions for areas where grassland is not a local habitat and would not be appropriate with respect to landscape character, e.g. wooded areas? And that's from Sarah Moore.
Yeah, I mean, very good point. There will be places where and plenty of them, where we're creating a wooded landscape, and there we should go to create the landscape that reflects the character of the area. So part of the reason for using the low fertility soils is to be able to create a character of the landscape appropriate to the geology of the area. So it's about creating habitats that are appropriate in the area. And if that's woodland, then you create woodland. Now, it is a debatable point as to whether you should, slap on loads of topsoil and plant the trees into it, or whether in fact you should be planting your woodlands into pretty unfertile soils. Because if you think about the way that most of our woodlands were established in a post-glacial period, they would not have been established on 150 or indeed 300 or 450 mil of topsoil. It didn't exist. So woodlands naturally come up on relatively infertile soils, and they create their own fertility, if you like. They create their own crumb soil mix as the woodland, the scrub and all the rest of it matures. And in terms of adding biodiversity into the woodland, in terms of the flora, the ground floor layer, as well as the scrub, the shrub layer and the tree canopy, my view is still very much that low fertility is best. But on the other hand, within the constraints of a highway network where we've got materials to move around and we want to minimize the amount that we're having to cart long distances, clearly woodland is going to be one of those areas which are going to consume the topsoils. But I would say that those woodlands that are planted on deep soils do have the least interesting ground flora, and that goes back centuries. So for where woodland was originally cleared and it's gone to grassland and then planted with trees, those ones tend to end up as being the ones which are least interesting from a ground flora.
I've got just a couple of points quickly. One is that there's been some really interesting work done with soil inversion through English woodland, and also from a colleague of mine, Richard Scott, amazing guy. So there's some interesting stuff going on around that, and specifically to create woodland. And as you say, Phil, that the ground flora is amazing in comparison to planting in topsoil. And just on the question of sticking to what's there or trying to mimic what the surrounding landscape is like, I think sometimes we need to think about how we can kind of add. Really, we don't have to have the whole thing copying what's around it. I mean, in the same way as this little scheme I'm doing up at the nature reserve, 260 acres of hawthorn scrub and ancient woodland, I'm suggesting we create an open mosaic habitat car park. That is going to bring in lots of new species. That is going to add to the biodiversity of that nature reserve. It's not going to detract from it. So I think there's opportunities to create pockets of different habitats and landscape that are going to pull in new species rather than sticking to what's already there.
Phil, you wanted to comment?
Yeah, just a follow on from what John said is you mentioned a phrase there I'm not quite sure that everybody will get, that those who are still with us, and that's soil inversion. That's an interesting one which we haven't mentioned, and that is the technique whereby you invert the profile of the soil. So you effectively take away the topsoil, bring up the subsoil, put the topsoil where the subsoil was, so you end up not actually moving any soils off site, but turning it round. So the topsoil gets buried and the subsoil comes to the surface. Now, once buried, if it is 1 to 2 meters buried, that's it. It's locked up forever down below the rooting zone. Now, you could say that was a waste of resource, and I think that's not unreasonable to say it's a waste of resource. But there are occasions when that is probably the right thing to do if we really are in a place where we want to max out biodiversity, we want to create the beauty in the landscape, but actually we have nowhere to put that soil. So we can't find a place to take it off scheme. Then soil inversion is a practicable example, and it is used in agriculture, in agricultural setting. in order to increase biodiversity on farmland.
Yeah, and I think Richard used it. I think it was a Dutch company that Richard had. It's basically a plough, a massive plough that flips over a whole metre of soil, completely turns it, and they had great success with it. Certainly.
Thank you. I think we're going to come to an end now. So I'm aware there's still more questions, and we will respond to these questions. And I'd just like to thank everyone for joining us today, and to Phil, Sarah and John for your presentations, which I certainly really enjoyed. And we hope that this webinar has inspired some ideas for how we can apply a more whole life cycle approach to linear infrastructure schemes with low nutrient topsoil, and maybe, yeah, inspire applications. But yes, if you have any more questions, please do get in touch with us here at ADAS, and my details are below. Thank you for your time.
Thank you.
Thank you. Bye.
Thanks. Bye.